So in this section, we're going to talk about measures of the center of data. The four parts to this are going to be the mean, the median, the mode, and the mid-range. If you need a way to help remember those, they all start with an M, so that might be a little bit of a trick for you. When we talk about the center of a data set, we're talking about the location. The two most commonly used are the mean or the average. That's probably the one you're most familiar with, and the median. Before we can go start calculating things, we have to be able to use the same notation so that we can communicate. So here we go. The first one is the capital Greek letter sigma. Sigma means you are going to add everything that comes after it. X is the variable we use to represent individual data values. So if you have a big, long string of data, each piece of data in that string is going to be represented by the X. N is still the number of data values in our sample. Capital N is the data values in the population. So make sure that these you keep straight. One way to think about it might be that the population is always larger than the sample. So the capital N goes with the population, and the lowercase n, that's smaller, goes with the sample. This next one is the average or the mean of sample values. It's an X with the line on the top. We call it X bar. X bar is the mean of the sample values. We have to keep that completely separate from the lowercase letter mu. Kind of like, I'm going to rewrite that. Kind of like the sound a cat makes. Mu is the mean for the population. So you have a couple of new things. You have capital N for population size, little n for sample size. X bar is the average of the sample values, and mu is the average of all of the values in the population. Now notice for our two mean values, it looks very similar. The differences being for the sample mean, we're going to use the sample size. For the population mean, we're going to use the population size. The other thing you'll notice is that we use that Greek letter sigma in there. This is the fancy mathematical way to say add all the data values in the sample and divide by the number of elements in the sample space. So we're not changing the operation that you're used to doing. We are just writing it in fancy math speak. When we do sample statistics, we are going to use English letters, the ones that you are familiar with. So that's the X bar. And when we deal with population parameters, remember a statistic goes with a sample, a parameter goes with a population. When we do parameters, we use the Greek letters. And there is the name of mu again. So we've talked about mean just a little bit in talking about the notation values. Just to reinforce, for the mean, we're simply calculating an average. That's not a new concept for you guys. What you need to realize is that we can connect the mean to X bar. That's the same as adding up all of the elements of a sample and dividing by the number of elements in the sample. And that's exactly the same thing as saying add all the things and then divide by the number of things. The good news is that if you have a big, long data set, we can plug that into StatCrunch and it'll do the heavy lifting for us. The mean does have some important properties that we've touched on a little bit in class as far as outliers go. But here's a more formal statement of its properties. So a mean or a sample mean draws from the same population tend to vary less than other measures of center. So what that means is if we take a population and out of that population we take several smaller samples. So maybe this group is a sample and this group is a sample and this group is a sample. If we find a mean for each one of those samples, as long as our sample is representative of the population, our means are going to be fairly close together. There's not going to be a whole bunch of change as far as size goes. The mean uses every single data value. When you calculate a mean, it's going to take into account every single number in that data set. One downside to the mean, and we've touched on this in class as far as looking at real estate values. One problem is that one extreme outlier, so one really high real estate value or one really low real estate value, can change the value of the mean. And that's something you have to be careful with when looking at the results of studies that you see advertised. Just because they give you an average of the data doesn't necessarily mean that average represents what's really going on. We say that the mean is not resistant to the measure of center, or is not a resistant measure of center, because it is affected so easily by those changes in outliers. We say that a statistic is resistant if the outliers do not cause a change in that statistic. The next one we're going to take a look at is the median. We've looked at median already, so this shouldn't change a whole lot for you. Remember, the median is the middle number in an ordered data set. It doesn't count if you don't put your numbers in order first. Quick review of notation. You might see a capital M. We might use MED as an abbreviation for median. Or remember, and we haven't used this a whole lot, we could use X with a little wiggle on top. A little more formally and a little more recently, we have looked at the median as being the 50th percentile or the second quartile. The other things that are important is that the median is resistant. Meaning it does not use the data values in the set, but more it uses the places or the order of the data. So it is not affected by the outliers. That is exactly what this first one right here says. The median does not change by large amounts when we include a few extreme values. And the median does not use every data value. It uses the data's position in our list of data. So keep those two things in mind. We talked about this as well when we initially talked about the median. Here's a little reminder for you. If your string of data has an odd number of elements, you find the median in the exact middle. If the number of data values is even, you're going to end up with two middle numbers, so you average them. Quick reminder right here, suppose that in a small town of 50 people, one person earns $5 million per year, and the other 49 each earn $30,000 per year. What is the best measure of the center, mean or median? So in other words, which value should you put more faith in? The center or the median? Well, if we look at the median first, our X with the wiggle on top. If I make a list of 50 people, the first 49 entries in my data set are 30,000. The last one is 5 million. That means my median, the number right in the center of that data, is going to be the $30,000. If we go calculate the mean, so we're going to go calculate X bar. We are going to add up all 50 pieces of data. So I have 5 million plus 49 times 30,000. So I add up all of the things and then I divide by the number of things. So I'm going to divide by 50. that results in an average value or an average salary of $129,400. Now, if you were considering moving to this small town and they tell you that the average salary is $129,000 a year, you initially think, hey, that's pretty good. But then if you go and look at what the data actually says, we only have one person making that $5 million a year. This guy is definitely an outlier. So the median is definitely going to be a better measure of center because it more clearly represents the data. So we're going to do one more example. I'm going to rely on StatCrunch for this one. We have AIDS data indicating the number of months a patient with AIDS lives after taking a new antibody drug. And they already order the list for you. We're going to calculate the mean and the median. You are welcome to calculate these by hand. I have already entered the data in a StatCrunch table. So I'm going to go to Stat. I want my summary stats. I entered my data in columns. I entered the data for this example in my first column. The third column is for a different one. I don't really care about where. I don't want to group them. I only want to look at two statistics. I want the mean and the median. So I'm going to uncheck everything else and click compute. So thanks to StatCrunch, I know that my mean, my X bar, is 23.57. We'll just leave it 5.8. My median is 24, which saves us a ridiculous amount of time. We will talk about mode and mid-range next.